Why, hello there, lovely ones. So, we are busy looking at trigonometry questions that can be found in paper 2 of November 2017. It is the IEB paper. This question over here, which is 3C, says calculate the general solution for theta, and we've got that information. Give answers correct to one decimal place. Now, generally, let's see what I did there. General solution is more of a grade 11 question. So this you need to have practiced quite a bit so that you could get all the marks here. I'm going to start by rewriting the equation. And while I do that, I'm going to remind you that general solution is pretty much just solving the equation. And one of the first things I notice as I'm rewriting it is that I have sine squared theta. And that, of course, means I've got a quadratic equation. So in order to solve any kind of quadratic equation, I'm first going to make it all equal 0. And then I'm going to look for different types of factorizing. Of course, I have the common factor. I have a difference of two squares. I have a trinomial. And I suppose we could look at a sum or difference of two cubes, but I highly doubt you will ever be asked that in the context of general solutions. So let's start by looking for a common factor. If I rewrite this as if it was algebra, I could write it as 3x squared minus 2x is equals to 0. And then the common factor is easy to see because I would take out x as a common factor, leaving me with 3x minus 2. If that helps you feel better as you do that, then, or do this question, then to the side, quickly scribble that down so that it's easier to take out the common factor in this over here. Of course, zero product rule says that anything multiplied together to get an answer of 0 means that both of those, or any one of those, could have a value of 0 when we solve for it. So that's why I'm now making each one of those factors equals to 0, and I'm now going to solve them as if they're two different problems. So let's draw a line down there so that it doesn't get too messy. Okay. Sine of theta equals 0. When you enter that into your calculator, more than likely you are going to get, you will get an answer of 0. And the reason you get that is because if we look at the sine function, we'll see that that over there, there, and there, those points in the normal sine function are where it equals 0. So solving the general solution for this, we literally just have to say that theta is equals to 0, and it reoccurs every 360 degrees, and that theta is equals to 180 because there it's 180 degrees, and it also reoccurs every 360 degrees. Okay, I'm squeezing it in a little bit over there. Of course, k is an element of any real number. Okay, but then on the other side, I have to do some manipulation first. So I'm going to start by adding 2 to both sides, and then I'm going to divide by 3 on both sides so that I have 2 over 3 sine theta. The next thing we need to do is look at our reference angle, and we use a calculator for this, which gives us 41,81 and 00 something something degrees. I know the question says one decimal place, but we are only going to round off in the very last step. So if we go back to our cast diagram, CAST, we've got to figure out where sine of theta is going to be positive, and I'm looking for that because I know that this fraction over here is a positive fraction. Sine of theta is positive in the first and the second, so I'm going to just write that down in quadrant 1, and then I've got quadrant 2 happening over here. Quadrant 1, we say theta is going to equal 41,8 degrees plus k times 360, because it reoccurs every 360 degrees. And then let's just put a little line to keep it separate. Over here I'm going to say theta is equals to 180 degrees minus 41,8 degrees, and let's just move over a little bit, plus k times 360, because it reoccurs every 360 degrees. And that means that theta equals 138.19 degrees plus k times 360. I am now going to do all of my rounding off, and I'm going to make it look pretty, and pretty work is easier to mark, so let's do that. Just on a side note, you should never ever erase anything. You should always just cross it out lightly. If you erase something, we can't mark it. Okay, so 0 degrees is equals to k plus 360. Okay, when I say erase, I mean don't even work in pencil. Pencil is not helpful to anyone. It must be pen and no Tipp-Ex, so no whiteout. So no, just use the pen. Okay, so theta is equals to 0 plus 360. Theta is also equals to 180 plus 360. It's also equals to, and now we're going to round off to be 41,2 degrees plus k times 360. And lastly, it's going to be equal to 138,2 degrees plus k times 360. And what is extremely important at this stage is that you do have k as an element of any real integer or any integer written at least once somewhere. The other way we could have just done the answers is we do a pretty little line under each one of those, but that means that you must remember to round off at this stage. So it's 41.2 degrees, and this over here would be 138.2 degrees. Let's just double check that we have answered the whole question. Question said, calculate the general solution for this over here. Give your answer correct to one decimal place. And we have 4 solutions over there. Well, my darling, that's it from me for now. Much love.